All right, Tara, there's a much easier way to do this one. It's not a ton easier, but it is a lot easier than what we were trying to do. So, remember when we were talking about velocity, we said velocity is equal to change in position over the change in time. And we know where both people start, we know how fast they're going, and we know that they're going to meet at the same time. So we were on the right track when we were trying to find that time. But there's an easier way to do it. Delta x is really equal to the final position of the person plus the original position of the person. So if we end up right here, which is really where we're going to end up, we can take their final position and subtract the original position, divide by the time it takes, and that tells us their velocity. So we're just using that fact to kind of help us out. And actually, this isn't plus. This one is minus. So it'd be the final minus the original position divided by time. So let's solve this thing for final position. If I do that, I'm going to just go ahead and multiply velocity times time. So that's v times t. I want to leave the xf on one side, which means I have to add the xo to both sides. So here's what we're going to do. For Brad and for Pitt, we're going to do the same thing. So here's Brad, here is Pitt, and we're going to use this equation. So we don't know where Brad is going to be. So that's going to be his final position. And we don't know where Pitt's going to be, but we know Pitt will be at the same spot. They both are going to be somewhere here. They could be anywhere, right? But we're just going to arbitrarily say they're right there. Now we're going to put in Brad's speed, and we see that Brad has a speed of 9 kilometers per hour. We're going to multiply that times the time, and we're going to then add to that the original position. But notice Brad's original position is minus 6 meters. Pitt, on the other hand, has a speed of 8 kilometers per hour. We're going to multiply that times the time, and then we're going to add Pitt's original position, which is plus 5. So because they're both going to be at the same spot, we can now solve for the time it takes for both of them to get there, because it's the same. So let's go ahead and do that. We're going to say 9 times t minus 6 for Brad is equal to 8 times t plus 5 for Pitt. Now, the other thing that we need to do is recognize that, remember, Pitt is moving to the left. And because Pitt's going to the left, we need to put in, for Pitt, a negative speed. So that's negative 8, and that makes this negative 8. So if you're going to the right, it's positive, and because this person's going left, their speed is actually negative 8 kilometers per hour, and this one is positive 9 kilometers per hour. So this is kind of why this one's an honors type question. If I add the two together here, I'm going to get 17t, and then I'm going to take 6 and add it to 5 since it's negative here, and that'll be 17t is equal to 11. I'm going to go ahead and solve for time, so my time now is equal to 0.647 or 0.65 hours. So that's how long it takes both of them to get to that meeting point. So now all we have to do is plug the time in to each one of these two equations, and that'll tell us their final positions. So let's go ahead and do that for Brad. So Brad's final position is going to be 9 times 0.647 minus 6. And if I do 9 times 0.647 and then subtract 6, I get negative 0.18 meters. So this right here, negative 0.18 meters, is where both people will be when they meet. So that would be the final answer. because that is the final position. And that should be it.